So today we are talking about a use case of Industry 4.0 and the company named Rittal, who is a pioneer of the smart factory in Germany. The company is the provider of industrial enclosure systems, including power distribution and climate control, as well as for IT infrastructure, software, and services. The company was founded back in 1961, and it started its digital transformation journey in 2012. The central product of the company is the control cabinets, which can be used in different areas, such as, for example, electrical engineering and automation, renewable energies, information technology, etc. Back in 2012, the company once introduced a digital twin. It was a big shift to the digitalized, more digital way of doing business. So this digital twin, or the prototype, was introduced, and it is very beneficial for the company at the different stages of the value chain. So our task was to consider how beneficial is this digital twin for the production stage. So Mathieu, could you please change the slide? Thank you. So we have considered smart production of the control cabinet. By using a digital prototype, Rittal has made the production more optimized and customer specific, and of course more effective. So first of all, we can see that the production is made more cost effective, since the control cabinets are produced only once a digital prototype is previously introduced. It is created, tested, and only after that the production is deployed. So in this way, there are no additional expenses for making physical prototypes and testing them, as well as the company also saves time. Also, we avoid additional expenses for unnecessary units, since we have very specific data provided by the customers. The production facilities are also adjusted, so there is no need after the units are produced. There is no need to adjust the system once again. And also, by introducing this digital prototype, the company has simplified to a certain extent also the integration of sub-components from different suppliers. In this way, it has improved the organization of communication with the suppliers. It can make better forecasts, and in this way also be more efficient. So now we will take a look on the patents.
Thank you, Natalia. So the first patent we found here is related to machining a switch cabinet and its flat panel. So the main idea here is to bring together all the machine parts belonging to the same cabinet using a machine readable identification. So you can see here on the picture, we have on the right hand side, we have the switch cabinet frame with the 201 is the identification label. And we have on the left side the flat panel, also with another identification label. And these two components are provided by two different manufacturers. It's what they explain in the patent. They are standard parts, standard components, so they are not customized. And the Rittal's customer need specific customization of the final switch cabinet. So maybe some holes here to allow wires or cooling. So they need a really customized switch cabinet. So what Rittal explained in the patent is that today they without digitization, sorry, they put by hand, for example, a label on the different components. So it brings a lot of mistakes because it's done by a human. So the first point related to the configuration and the product. So here the product are the cabinet elements, the panel and the frame. They are configured to be reassigned together to easier their reassembly after machining. And yes, they say accordingly, it's provided that the switch cabinet has an individual machine readable identification. We guess it's like a QR code, but it's not limited to QR code. And the removably mounted component, here it's the flat panel, has an individual machine readable identification also. So they are assigned to each other. The second point related to optimization of the process step. So the switchgear cabinet production process steps are optimized for better efficiency and avoiding error, like I said, especially component identification error, to be sure that you take the right flat panel with the right frame. They fit together. So I will not read everything, but in a nutshell, which is very interesting here is thanks to the digital twin, so the digital prototype, even before the two components are manufactured, even before they are already associated together. They have the identification, and it's already done virtually. So it's very, very interesting. They say in the earliest possible manufacturing process, you see the components are assigned. They have the information concerning the post-processing of the respective component via the link with the component identification. So they can provide a highly individualized component to the customer in the raw production process. So now, very quickly to show you how this patent fits in this digitization taxonomy, you see in the product configuration part, and also in the process step optimization. So I will not repeat what I already said, but to allow you to see how it fits. Now I let my colleague explain this second patent.
Okay, for the next patent, this PCT application basically has a pick and place robot that mounts the components based on planning data. So it has logic control, procedure, and classic algorithms, as it makes use of the planning data generated during the development of a switchgear or a control system with the help of modern software-supported engineering system to establish an automated assembly of the mounting. So this data, we call this machine data, controls the pick and place robot, allows for the establishment of an automated assembly of the mounting plate. Basically, this application is an optimization method as it becomes possible to automate those non-automatable processing or assembly steps with the methods described in this patent application, such as, for example, two components which are arranged too close to one another can be automatically positioned on the mounting plate with the assembly robot. So the general steps involved in this patent application are the reading the planning data of a switching or control system into an automatic placement machine, which has a placement robot, then extracting the position data of at least one fitting component to be mounted on the mounting plate, then detecting a spatial orientation with an image processing system of the pick and place robot, then assigning the position data to at least one position on the mounting plate, then executing at least one processing or fitting step linked to the position of the mounting plate. So there are also components. The components include the mounting rails, cable ducts, small and series components, large and individual components, and fasteners, such as screws and rivets. So these components are available in different designs so that they can be picked up and positioned and mounted in the mounting plate by the pick and place robot. For the next slide, for the digitization taxonomy, as mentioned, there is logic control and then procedure, which involve algorithms for the automated assembly of the mounting plate. The patent application can be considered as an optimization patent because it can automate some non-automatable processing or assembly steps. It involves some process steps as previously described, mentioned. Then lastly, the components, as mentioned, the mounting rails, cable ducts, some components, large and individual components, fasteners, such as screws and rivets. So I now hand you over to my colleague.
Yes, and as an insert example for our smart production, we have here an automatic wiring process for electronic components that is based on predetermined ECAD data and positioning data for the switchgear construction. And we have thereby two input data. One's the ECAD data that contains the plan of the switchgear and the circuit diagram. And on the other hand, a second input data that is based on the sensor data that is containing positioning and the orientation of the actual position of the wiring robot. And based on that, the wiring robot is then configured and generate the control data is configured and generated to then move the wiring robot to the right place. Furthermore, the reposition of the components then gets also identified by a barcode or by an RFID code, and can be then compared also with this simulation data, like the ECAD data of the switchgear plan and the circuit plan, to then allow us to correct the position, to optimize our position a little bit. So exactly, these are the two main points of the patents. And to now categorize this patent in the taxonomy, we was considering that this patent fits good into the logic control and is simulating, optimizing the process steps.
Thank you, Tobias. So now we are going to talk about how this patent were relative to the use case. And as you remember, the previous group has presented somewhere the engineering mechatronic, and now we are more on the smart production part of the whole process of Rittal. So these three patents just presented are relating to digital twins, because we have a parallel between the real world and the virtual world. So in the real world, we mention configuration, simulation, optimization based on the planning data. Here, Matthew has the activity started from the review and selection of components that may be relevant for the request, as you can see on the bottom side of the virtual world. And then he ran to the real world. So real world, we are in our part with production instruction for features and drivers ordered to the robots, quality control, spatial position, mechanical and electrical testing. And here, so we stand to the selection of the control cabinets. As you remember, it was with labeling and way to identify each element. Then it's also defined required modification of the cabinet in the software in ePlan. And it also generates production data in the solution for all overall the value chain. For the patent of Tobias, we are more on the optimization of design and it also generates production data for the e-plan software. Sorry. And for Rudina, we will more on the way that place component and breakout. So how the elements are, you remember, just pick and place by the robots, and checking the placement of the component through the digital twin, and then also provide generation production data to the digital twin. Thank you. Pierre is going to continue with the pattern types.
So having a patent portfolio is something, but at the end, most important, what really counts is that these patent or protective features that you really want to be exclusive because they generate a benefit to your company. And what we did here to run such an analysis and check the relevance of these 3 patents, we went for a problem and solution approach. And what we find out here is that these 3 patents are not here by hazard somehow, but they are really protecting 3 critical steps in the production facility at Rittal, which is the machining of the parts, the placement of the component in the cabinet, and at the end, the wiring. And something in, I will not go again in detail in this patent, obviously, but something that we found in common here is that really each of these patents, as you can see in the solution column, is taking production data from the virtual world, as already said, doing simulation, and then sending concrete orders in the real world, in fact, either to the fitters or to the robot, to optimize the production process and gain benefit already as of the batch 1. In traditional production, I mean, usually, the first time you start your process, you would have a rather high scrap rate. In this case, you can benefit from the first element of all the benefit having a high quality. So that's really a way also to gain flexibility in the production. And all these 3 patents somehow at the end will really protect main features in Rittal production. And that's a way to really increase Rittal profitability, increase their competitiveness on the market, and by enhancing the quality, reduce the lead time and reduce their costs. And obviously, quality and lead time are very important values for their end customers. So that's a way for them to be stronger than competitors.